if we have several independent samples and we need to compare the different populations as far as their parameters are concerned, then we can make use of the analysis of variance that is known as ANOVA. So ANOVA is a parametric technique that is used to compare the several means that are the location parameters of the population, and we will have to make a comparison that whether the means of all the groups that we are considering are the same or they are different from each other. One of the assumptions about the ANOVA is that the populations from which the samples are to be drawn, they have to be normal. And the second assumption is that the variances must be equal. The population variances has to be equal. So if one of the assumptions of ANOVA are not met, then we will have to look for the non-parametric alternative of the ANOVA. The non-parametric alternative that is widely used in order to test the several populations is known as the Kruskal Wallis H test. It is perhaps the most common and widely used test in order to compare several samples that are being taken independently or they are being taken from identical populations. So basically, Kruskal Wallis H test is also known as Kruskal Wallis one-way ANOVA that makes use of the ranks. So we are not going to take on the actual observations, rather we'll be converting our observations into the ranks, and then for example, if we have arranged all the observations, then the smallest rank is to be assigned to the smallest difference between the medians, and then the largest rank is to be assigned to the maximum difference that is being given to us. So when only two samples are being compared and the two samples are considered to be independent, then Kruskal Wallis test is the same as that of the Mann-Whitney U test. Kruskal Wallis test is more powerful and is preferred when the data are measured on at least the ordinal scale. Now students, in order to apply the Kruskal Wallis H test, we'll have to follow certain assumptions. Although these assumptions are not the stringent assumptions, but still if these assumptions are met with the data sets, then we can apply the Kruskal Wallis H test. The first assumption that we are going to discuss is that the data for analysis, it consists of k random samples of sizes n1, n2, so on up to nk. So students, ये जो k random samples हैं, obviously they are drawn from several independent populations. Then the next assumption is that the observations are independent both within and among samples. That means, for example, if we have three groups, x1, x2, x3, and there are certain number of observations under x1, x2, x3. Let us suppose under x1 we have 1, 2, 3, 4, 5. Then under x2 we have 2, 4, 7, 9, 10, 11. Under x3 we have like 1, 3, 5, 7, 9, 11. So we are assuming, as far as the second assumption is concerned, that the observations under x1, they are independent of each other, and the observations under x2 are independent of each other. The observations under x3 are independent of each other, and further, the observations among the samples, they are independent of each other. Similarly, these assumptions, the observations under x2, they are also considered to be independent of x3. So that means the observations within the sample and across the samples, they are independently being drawn. Then the next assumption is that variable of interest has to be continuous. That means it can be measured onto interval scale or onto the ratio scale of measurement. Then the fourth assumption is that the measurement scale is at least ordinal. But it will be good enough that if our measurement scale will be interval or ratio. And lastly, we have that the populations are identical in their shape. So we are assuming that their shape is almost the same. That means they are identical of each other, except there is a possibility of a difference in the location for at least one population. But otherwise, we are assuming that as far as the shape is concerned, the populations are somewhat identical to each other. So they are just being different as far as the locations of those populations are concerned.